Hello and welcome to another video. My name is Howless and today I want to talk about critical race conditions and mutex locks in C. So a critical race condition occurs when two threads or processes depend on the same shared state. An example of this could be when two threads are using the same variable. So when two threads share the same global state, they may interfere with each other. In order to ensure the correctness of a program, we need a way to prevent them from interfering with each other. In the C programming language, a common way of protecting the threads from interfering with each other is using a mutex lock. So right now I'll give an example of what happens if we don't use a mutex lock and two threads depend on the same shared state, like the same global variable. So I'm going to call it bad example. Let's see. So first I'll just add the usual includes. So the pthread library is what we're using to create multiple threads. So this is going to be my global shared state in this example. So it'll be an integer counter. I'm going to set it to 0. So I'm going to create a function that doesn't really do anything, it just increments the counter. Just give it a big number. So all this loop is going to do is just increment the counter for each iteration. Right now I'll write the main section of the program. So I'll just initialize the threads. So T1 and T2, so just initialize two threads. Actually, I'm not going to do it, just declare two threads. Declare two threads, and now we name threads. Let's go create. For this example, I don't really want to give the other arguments. So in this example, I'm just hard coding the threads. All I'm going to do now is just going to print the counter. And a new line at the end. So if I just save that and compile it. So if I run this now, you would expect the counter to be like 2 million instead, and you can see every time it's a different value. You can see that we get a different value every time. This is because the threads are interfering with each other. So the threads access that shared state memory at the same time. Let's say the counter is at 5, both of them access it at the same time, and they both increment it to 6. Instead of one accessing it after the other, and that's why we get these random values. So now I'm going to show you a way to fix it. So a way to fix it is to use a mutex lock to ensure that only one thread is accessing that shared state at a given time. There you go. So if I go, let's see, and I want to fix this. So way to fix this would be to, first of all, I'm going to declare a global mutex. So this is my mutex variable. After I declared my threads, I can init my mutex. Yeah, to initialize the mutex. So do thread mutex init. Pointed to mutex variable. So right now in the function, I want to ensure that only one thread is accessing that counter at a given time to make sure that the threads don't interfere with each other. So what I'm going to do is I'm going to lock the counter before incrementing it. Before increment, multithread, mutex, lock, mutex. So after it's done incrementing, after the increment, we'll unlock the counter, thread, mutex, unlock, and point to the mutex variable. So right now, if I compile this program, I do cc lux.c and I run it, you can see that the counter is at 2 million every time now. This is because the counter is locked and only one thread can access it at a given time. So as one thread is executing the increment, the other can't. And it's waiting for that counter, for that shared state, the counter to be unlocked. And once it's unlocked, the other thread executes the increment. Yeah. So this is a very basic example with hard-coded threads. However, it shows why we should use a mutex and why this is useful to ensure the correctness of a program when having more than one thread or a process with the shared state. So thanks for watching, and see you again in the next one.